Guys, on this video I am going to show you how to do dimensional analysis. This technique called dimensional analysis is used to convert from a given unit to a desired unit, and this is a universal method. It works for a lot of different fields. You can use this method, the system, in the culinary conversions. You can use this on chemistry, you can use this on physics, you can use this in a galore of different fields. Okay, so let's go ahead and talk about the principles of dimensional analysis. First of all, what you need is to have some conversion ratios or conversion factors. Okay, and those conversion factors are these numbers that I have here. Okay, and I got those from a table. If you guys can memorize those numbers, that'll be great. If not, just make sure to have a table with you with all of these values, because those are given values. Those are values that are not going to change. Okay, and those are values that we're going to be using from now until the end of the term. Okay, so just reading those from top left to bottom right. This is 1 gallon equals 4 quarts. Okay, 1 gallon equals 8 pints. 1 gallon equals 16 cups. 1 gallon equals 128 fluid ounces, and so on and so forth. Okay, so I have all of those different units. These conversion ratios or conversion factors are volume conversion factors. So these are helping me convert from one volume unit to another volume unit. Okay, so let's go ahead and start doing the conversions. Okay, the problems themselves are going to look like the ones that are showing in red. The first problem says we're converting 5 cups to gallons, so we're not changing any volume. Okay, the volume has to remain the same. We're just using a larger or a smaller container to measure this. That's why the number is going to change. Okay, so 5 cups is equivalent to how many gallons? And this is how I'm going to start the dimensional analysis. You always start with the given quantity. In this case, the given quantity is 5 cups. This is what I'm going to start with. Okay, 5 cups. I'm going to write it down. And then I'm going to start a series of multiplications and divisions until I convert to the appropriate unit. And the way to do this is I'm going to write a times sign. So the number, the given unit, you can think about it as written over 1 always. I don't like to write this because it deceives some people. So I'm just not going to write the divide by 1. You don't have to worry about it, okay? But on the next line, because this is going to be a series of multiplications or multiplications and divisions. Okay, on the next line, I'm going to write the conversion factor that takes me from cups to gallons, or from gallons to cups also. Okay, whichever of the quantities in black that talks about cups and gallons is the one that I'm going to use. And as you can see, the one that relates cups to gallons or gallons to cups is the same thing, is the 1 to 16. So what I'm going to do is I'm going to rewrite this conversion or this conversion equality, this 1 gallon equals 16 cups, as a fraction, so that the units that are given, the 5 cups that are given, cancel out with the cups in the conversion factor, at least the units, and that's going to guide me into gallons. Okay, so the way to do this is I'm going to write cups here on the bottom and gallons over on the top, because for dimensional analysis to work, you have to be able to have the same unit on the top and on the bottom, and that way the remaining unit is going to be the one that carries over in the result. Okay, so again, I'm using a conversion factor that talks about gallons and cups. All of the other conversion factors that I'm showing here are not going to work for this purpose, only the gallons to cups. Okay, and now I don't just have to write the units in the dimensional analysis, I also have to write the quantities or the dimensions. Okay, the 1 and the 16, it says that the 1 goes in the gallons, so 1 goes here, and the 16 goes in the cups, so 16 goes here in the bottom. Okay, that is because my conversion factor says 1 gallon equals 16 cups. And why do I have the 1 gallon on the top and the 16 cups on the bottom? Because the given unit is cups. Given unit has to go on the bottom now, so that those two cancel out when I carry over my dimensional analysis. Okay, that's the reason why I'm putting the 1 on the top and the 16 on the bottom, because that's what the units are telling me to do so. Okay, now once you reach the desired unit, which is gallons, you just have to do the math. And the way to do the math here is multiply all the numbers in the top and then divide all the numbers in the bottom. So what I'm doing here is I'm multiplying 5. I'm going to write it down, right? I don't usually write this down, but that's 5 times 1. Okay, and I'm dividing by all the numbers in the bottom, which is a 16. Okay, and I'm just going to plug it in the calculator straight. 5 times 1, that's 5. 5 times 1, that's 5. Divide by 16. This is 0.3125 gallons. And that will be my equivalent for 5 cups. Okay, again, dimensional analysis works because we have all of these conversion ratios here, okay, that we can play with as long as the units cancel out with the given unit, in this case, the cups that we're starting with, okay, the 5 cups. So you cancel out the units, you don't cancel out the numbers, okay, you use the units in order to guide you as if you're doing a multiplication or division of the numbers, okay. So let's go ahead and do a second one. I'm going to scroll up a little bit. This is 2 tablespoons and we're converting to teaspoons. Dimensional analysis says I'm going to start with the given quantity, so 2 tablespoons. And I'm going to do a series of multiplications and divisions. Okay, multiply times the top, divide by the bottom. Since I have tablespoons as the given unit, I'm going to write tablespoons on the bottom. Okay, this is meant to be a capital T, I'm sorry. And the desired unit, which we're converting to, those are teaspoons. I'm going to write it on the top. Okay. Now I'm going to go to my conversion table or my set of conversions and find something that relates tablespoons to teaspoons. Okay, so I'm going to scroll up, find a number that's related from tablespoons to teaspoons, and the one that I see that is related is 1 tablespoon equals 3 teaspoons. Okay. All of the other conversion factors, they don't relate tablespoons to teaspoons. And the numbers that I'm looking at right now is 1 in the tablespoons and 3 on the teaspoons. Okay, so let's go ahead and take those numbers, 1 in the tablespoon and 3 on the teaspoons. So according to my dimensional analysis, 1 goes in the tablespoons and 3 goes in the teaspoons. Okay, those are my conversion factors, just converted into a fraction or into a building block of the dimensional analysis. Okay, so in this case, tablespoons, just the units, they cancel out. Okay, tablespoons and tablespoons cancel out, and this is going to be the remaining unit on my result. All that's left is the math to be done, which is multiply the numbers in the top. So this looks like a 2 times 3 divided by 1. This number's over here. 2 times 3 divided by 1. 2 times 3, that's 6, and 6 divided by 1, that's 6. And the remaining unit is teaspoons. This is the only one that we didn't cancel out. Okay, this should be my result, converting 2 tablespoons to teaspoons. Okay, let's go ahead and do the third one. 10 fluid ounces, we're converting to milliliters. Dimensional analysis says we start with the given quantity. And we're going to start the series of multiplications and divisions. Okay, the given unit, goes in the bottom. And the desired unit, which is milliliters, go in the top. Now I'm going to go back to my conversion table and I'm going to look for a number that relates milliliters to fluid ounces. Okay, so I'm going to go back up here, milliliters and fluid ounces. The number that relates those is 1 fluid ounce equals 29.59 milliliters. Okay, so 1 goes in the fluid ounces and 29.59 goes in the milliliters. Okay, so 1 in the fluid ounces, 29.59 goes in the milliliters. Now at this point, the units are going to cancel out. A fluid ounce in the top cancels out with a fluid ounce in the bottom. Use the units, not the numbers. And the remaining unit is milliliters, which is my desired unit. Okay, let's go ahead and do the math. So this looks like a 10 times 29.59 divided by 1. So if you do this in the calculator, that's going to be 295.9, and my remaining unit is milliliters. Okay, 10 times 29.59 divided by 1 is 295.9 milliliters. Okay. Next one is going to be 3 quarts converted to fluid ounces. So we start with the given quantity, which is 3 quarts. I'm going to start my series of multiplications and divisions. Okay, quarts, which is the given unit, goes in the bottom now. And fluid ounces, which is the desired unit, goes on the top. Now I have to go up to my conversion table and find number that relates fluid ounces to quarts. Okay, number that relates fluid ounces to quarts looks like this one. 1 quart equals 32 fluid ounces. Those are quarts to fluid ounces or fluid ounces to quarts. It doesn't matter how you see this. Okay, it's a relationship. It means that 1 quart has 32 fluid ounces. Okay, so 1 quart equals 32 fluid ounces. 1 goes in the quarts, 32 goes in the fluid ounces, because that's what the conversion factor says. It's just converting to a fraction. Okay, quarts cancel out. So my result is 3 times 32, so multiply tops and divide by the bottom. And this result, if I do it in the calculator, is going to be equal to 96 fluid ounces. 96 fluid ounces. Okay. Next one, let's go ahead and convert 16 teaspoons, small spoons. We're converting this to cups. Okay, so 16 teaspoons, we're converting to cups. Dimensional analysis says we start with the teaspoons. We're going to start a series of multiplications and divisions. The given unit goes in the bottom. Teaspoons go in the bottom. The desired unit, which is cups, go in the top. And now I have to look up in my table and find a number that relates cups and teaspoons. Okay, let's do a quick check. Let's see, we have a number that relates cups and teaspoons. Okay, and just by looking at my table here, I don't have any relationship between cups and teaspoons. Okay, so I'm gonna run into a situation where I have to do several step dimensional analysis. Okay, so this process that you're doing is not gonna stop after the first series of multiplications and divisions, but you're gonna add a second building block. And you guys have to define this. Okay, you have to define your path. So since I'm starting at teaspoons, okay, I need a conversion factor that has teaspoons. That's gonna help me jump into cups. So teaspoons, I only see teaspoons here, and that's it on the numbers that I have. Okay, so it looks like I can only convert from teaspoons to tablespoons with the 1:3 or 3:1 ratio that I just highlighted here. Okay, so I can convert into tablespoons first. Okay, and then I can convert from tablespoons to my desired unit, which is cups. And I do have a conversion factor between tablespoons and cups. So I'm gonna place these values in the dimensional analysis, making sure that the units cancel out. Okay, one unit that you have in the top has to cancel out with a unit that you have in the bottom in the next block. Okay, so I'm gonna start with the given unit, which is teaspoons, and instead of going to cups, okay, I'm gonna do a stepstone, and I'm going to convert to tablespoons first. Okay, and I'm not going to perform the result. I'm just going to leave it hanging. Okay, the conversion factor is 3 teaspoons to 1 tablespoon. If I go up and look at the conversion factor, okay, 3 teaspoons equals 1 tablespoon. Okay, and my second conversion factor is 1 cup is 16 tablespoons. So what I'm going to do here is I'm going to not hit equal. I'm not going to do the math yet. I'm going to add an extra step where my new given unit is tablespoons. So that means that this unit has to go on the bottom, tablespoons, and my actual desired unit goes on the top. So it looks like I'm using tablespoons as a stepstone between teaspoons and cups because I do not have a conversion factor from teaspoons to cups. in the given set of conversion factors. Okay, so what are the numbers that I'm gonna place here for tablespoons and cups? Well, it's a 16:1 if you look at the table, okay, and the 16 comes in the tablespoons, and the 1 comes in the top in the cups. Okay, so now I can go ahead and do the math, because teaspoons cancel, use the units, tablespoons cancel, so they serve the purpose of being the bridge, and I end up in cups, which is my desired unit. Okay, let's go ahead and do the math. This math looks like 16 times 1 times 1 divided by 3 times 16 on the bottom. Okay, so I'm going to show you how to plug this in the calculator, because the rule says you have to multiply everything on the top and you have to divide everything on the bottom. So the proper way to set this up in the calculator, so that you don't have to round in between steps, is start multiplying everything on the top, 16 times 1 times 1, okay, and without hitting equal, then you're going to start dividing everything on the bottom. So divide 3 and divide 16. Okay, so multiply everything on the top, divide everything on the bottom. I know it says multiply here, right? Because if you do this operation first, you have to do it as a multiplication, then carry it over. Okay, this is going to be a 48 and this is going to be a 16, and then you can go ahead and do the fraction. Okay, but it's going to be simpler if you just do this process in the calculator. Okay, it's going to save you a lot of time and a lot of writing. So do the test. See if this operation in the calculator gives the same as this operation in the calculator. Okay, remember it says multiply all tops, multiply and then divide by all bottoms. So here I should have 16 times 1 times 1, which is 16, divided by 3 and then divided by 16. It leads to 0.33 repeating, and my units are cups, which is 0.0 or 0.3 repeating is the same thing as 1/3 of a cup. Okay, you can leave it as a decimal, but sometimes it's easier to talk about fractions. Okay, 1/3 of a cup, you should be familiar with 1/3 of a cup, 1/2 of a cup, 3/4 of a cup. Okay, so either or decimal or fraction, this is correct. The thing to highlight here is the several step or multi-step dimensional analysis that you guys will have to be doing in this term and the following term. Okay, let's go ahead and do the next one. 3/4 of a cup to fluid ounces. So dimensional analysis says we start with the given quantity, 3/4 of a cup, and I'll recommend you to convert this fraction into a decimal. It's easier to start with a decimal when you're doing dimensional analysis. Okay, so instead of saying 3/4 of a cup, I'm going to start with 0.75 cups. This is where I'm starting, which is the 3/4 of a cup. I'm going to start my series of multiplications where the bottom unit is cups and the desired unit is fluid ounces if I have this conversion factor on my table. Okay, so I'm going to go back to the table. Fluid ounces to cups is what I'm looking for. Okay, fluid ounces to cups looks like 1 cup equals 8 fluid ounces. That's fluid ounces in cups that are related in that conversion factor. So 1 goes in the cup, 8 goes in the fluid ounces. 1 goes in the cup, 8 goes in the fluid ounce. And then I'm going to do my multiplication. Since the units cancel out cups, the remaining units fluid ounces, that's the unit that I want to convert to. Okay, so 0.75 times 8 divided by 1. That's going to give me my result in fluid ounces. 0.75 times 8, that's 6. And then divided by 1, that's just 6 fluid ounces. That's 3/4 of a cup in fluid ounces. Okay, the last one that I'm going to perform on this video is going to be 4 cups to milliliters. According to the dimensional analysis, we start with the given unit, given quantity, given unit, and then we're going to do a series of multiplications where the given unit goes in the bottom and the desired unit goes in the top if we have this conversion factor on my table. cups to milliliters. So let's go back to the table. And it looks like I don't have cups and milliliters or cups to milliliters. Okay, the conversion factors that involve cups are the following ones: 1 gallon, 16 cups, 1 quart, 4 cups, 1 pint, 2 cups. Okay, 1 cup, 16 tablespoons, 1 cup, 8 fluid ounces. And those are the only ones that involve cups. Okay, since I'm jumping to milliliters, I have to note also which are the ones that involve milliliters. And in this case, I just have a couple of them, right? 1 liter equals 1,000 milliliters, and 1 fluid ounce is 29.59 milliliters. Okay, so it looks like I need to jump from cups to a stepstone. Let's go ahead and call this stepstone fluid ounces. Why am I choosing the one with fluid ounces? Because I also have a conversion factor 4 mLs that is related to fluid ounces. So those are the ones that I'm going to use. I'm going to use fluid ounces as the bridge between cups and milliliters. Okay, so I'm converting from cups to fluid ounces first, and then fluid ounces to milliliters in the same dimensional analysis, in the same set of multiplications and divisions. Okay, so 1 cup is 8 fluid ounces. Those are the first numbers that I'm going to do here. Okay, I'm not converting from cups to milliliters yet. I'm converting from cups to fluid ounces, and the numbers that come in the table is 1 in the cups, 8 on the fluid ounces. And if I were to stop there, the result would be fluid ounces, which is not what we want. We're just doing fluid ounces as a stepstone, as an in-between step. Okay, I need to keep going because that's not my desired unit. And on this case, the new given unit or the intermediate given unit is fluid ounces, so that goes in the bottom. And my desired unit is milliliters. That's why that goes in the top. And now I can use the conversion factor from fluid ounces to milliliters, which is the one in green. 1 fluid ounce is 29.59 milliliters. So 1 in the fluid ounce, 29.59 in the milliliters. Okay. You hit equal because cups cancel, just the units. Fluid ounces cancel. And the remaining unit after you do all the math is milliliters. Okay, so let's go ahead and do the math. Multiply all tops. 4 times 8 times 29.59 divided by 1 divided by 1. Okay, so let's go ahead and do this on the calculator. 4 times 8 times 29.59, and it's all divided by 1 equals 946.88 milliliters, and this is my equivalent for 4 cups. Okay, 2-step dimensional analysis. Sometimes you're going to require to do even 3 steps dimensional analysis, and this is how you perform it. Okay, if you have any questions, go ahead and send me an email or leave a comment on this video so I can go ahead and address it. Have a nice day.